A stranger from another star has slipped into our solar system, and it didn't sneak in quietly. 3. I divided by Atlas is racing faster than any comet we've tracked before, 135,000 miles per hour. Yet, it has chosen a path that runs almost perfectly along the plane of the planets, as if it knew exactly where we would be watching. Its coma ignited too early, its chemistry seems out of balance, and some astronomers whisper of pulses of light and curious signals. Is this just an unusually volatile comet, or something more, a messenger designed to be seen? Tonight, we'll chase the evidence, weigh the mysteries, and ask whether we're ready to recognize a sign from beyond. Because sometimes the most important question is not what's out there, it's how we respond when it arrives. How can something that doesn't belong here arrive as if it already knows the way? That question has been echoing in my mind ever since astronomers in Chile spotted a faint streak across the dark winter sky on the 1st of July, 2025. They didn't realize it right away, but what they had captured was no ordinary comet. This was an interstellar traveler, only the third we've ever recorded a visitor named 3I divided by Atlas, slipping silently into our solar system with the calm certainty of a messenger that has traveled for millions, perhaps billions, of years. Welcome, my friends, to Velocity of Comets. I'm glad you've joined me tonight. Together we explore not just the cold facts of space, but the wonder they awaken in us. This journey is not mine alone. It belongs to all of us who look up at the sky and wonder what lies beyond. So take my hand, and let's walk together into the mystery of this new arrival. Imagine you are standing with me at the observatory in the Atacama Desert. The air is dry and still, the Milky Way spills across the heavens in dazzling clarity, and the telescope's dome rotates with a low metallic sigh. On the screen, a faint dot streaks slightly from one frame to the next. At first, it could be mistaken for space debris or a common comet, but within hours, astronomers realized something was different. The orbit was too steep, the speed too high. No matter how much gravity the sun pulled with, this object would never circle back. It was passing through, forever unbound. Its speed alone is staggering, about 135,000 miles per hour. That's faster than any spacecraft humanity has ever launched. Even Voyager 1, our most distant probe, crawls by comparison. And yet here it is, this traveler from another star, moving so quickly that no solar tether can hold it. But speed is not its only surprise. The path it takes is stranger still. Rather than cutting through at some random angle, as you might expect from a wanderer tossed out of a foreign system, 3I divided by Atlas slides almost perfectly along the ecliptic plane, the thin disk where nearly all the planets revolve around the Sunday. Do you know how rare that is? Astronomers say the odds are 1 in 20,000. And yet here it is, gliding right where our eyes and instruments are best prepared to see it. I confess, the first time I traced its orbit on the chart, a shiver ran down my spine. It felt too perfect, too coincidental. Rationally, I know chance can produce such alignments. Space is vast, statistics allow for miracles. But emotionally, it feels like a performance staged for us, as though the cosmos itself were saying, "Look closely, don't miss this." What makes this timing even more remarkable is where Earth will be when 3I divided by Atlas reaches its closest approach to the Sun on the 29th of October. We'll be on the opposite side, hidden from the best vantage point, almost as if the object chose a path that lets it slip behind the curtain just when the spotlight should have been brightest. Coincidence? Maybe. But that tension, that sense of almost seeing, almost knowing, fuels the mystery. Still, even without a front row seat, we are far from blind. Mars will lie near the comet's path, and NASA's Mars Reconnaissance Orbiter carries HiRISE, the sharpest camera ever sent to another planet. Designed to photograph the Martian surface in astonishing detail, it now has a chance to pivot outward, to try and capture images of a visitor from another Sunday. Picture that, a spacecraft orbiting Mars, turning its eye away from the red deserts below, stretching its gaze outward into the night to catch a ghostly traveler speeding past. That thought alone makes me stop and whisper thanks for the technology we've built, for the timing that allowed it, and for the sheer audacity of attempting to photograph an interstellar comet from another world. And this is only the beginning. Jupiter, the giant of our solar system, waits farther along the path. Its gravity may not capture 3I divided by Atlas, but it will bend the trajectory, nudging it slightly as it sails past. Some scientists have even suggested using our orbiters around Jupiter, or perhaps redirecting the veteran Juno spacecraft to take a last daring look. SpaceX has also entered the conversation indirectly by demonstrating how quickly we can launch payloads into space. Imagine, just a few decades from now, a starship ready on the pad, carrying a small probe that could intercept the next interstellar visitor on short notice. 3I divided by Atlas reminds us not only of what we see now, but of what we could prepare for in the future. But let me pull you back to the present. Standing at the telescope, I can see the faint fuzz of a coma already forming around the nucleus, even though the object is still far from the sunday. That's unusual. Most comets wait until they draw near, their ices boiling off under heat. But this one woke early, whispering its presence while still in the cold outer reaches. Early activity means unusual chemistry, volatile ices perhaps, or something we've never seen before. My pulse quickens. The cosmos has handed us a puzzle, and every spectrograph, every photometer, every camera we have is now trained on it. And then there is the human side. The thrill of belonging to a species capable of noticing this faint dot at all. Just think, for millions of years, 3I divided by Atlas wandered between the stars unseen, untouched, carrying with it the secrets of its birthplace. And only now, in the brief century when humanity has built sky survey telescopes, does it arrive in our neighborhood. What are the odds that we, fragile newcomers on a tiny blue world, would be here to greet it? This is where awe meets humility. We don't yet know what 3I divided by Atlas truly island. We don't know if it's merely an icy remnant, or if it hides surprises deeper still. But what we do know is this: the universe is speaking in events, not in words, and this event says, pay attention. That's what I ask of you now. Stay with me on this journey, because we're not only chasing an object, we're chasing understanding, and the way it reshapes who we are when we look outward. So let me ask you, if you had the chance to witness a messenger from another star, would you turn away? Or would you lean closer, eyes wide, daring to believe the story it might tell? I know my answer. And I invite you to join me, side by side, as we follow 3I divided by Atlas across the sky, into the unknown. Together we will measure, question, wonder, and perhaps discover more than we expected. Because awe is not a distraction from science, awe is the fuel that carries us to truth. The night after I first traced the path of 3I divided by Atlas across the charts, I couldn't sleep. I lay awake, hearing the hum of the observatory's cooling fans still buzzing in my mind. Every time I closed my eyes, I saw that hyperbolic orbit again, an escape path that would carry this object out of our solar system forever. And I wondered, are we witnessing a frozen relic of another sun, or something stranger, something we've never dared to imagine? Science is not about clinging to one answer, it's about testing every possibility. So let me walk you through the possibilities the way we discuss them late at night over glowing monitors and coffee-stained notes. Some are conservative, some are bold, but each deserves a fair hearing. We begin with what we know. 3I divided by Atlas is moving too fast to be bound by the sunday. That alone marks it as interstellar. Its coma, the hazy envelope of gas and dust, appeared earlier than most comets, forming well beyond Jupiter. That suggests its body contains volatile ices, like carbon monoxide or carbon dioxide, that sublimate far more easily than water. NASA's James Webb Space Telescope, with its exquisite infrared spectrographs, has already turned its mirrors toward the object. Early reports suggest something remarkable. This comet is unusually rich in carbon dioxide, 8 times more abundant than water vapor. That ratio is the most extreme ever recorded. What does it mean? The simplest answer is that it formed in a nursery rich in CO2, perhaps in the colder outer reaches of another star system. That would make it a kind of chemical time capsule, carrying the fingerprint of an alien birthplace. But the truth is, even simple answers are never simple in space. Why so much carbon dioxide? Could it be that our models underestimate how diverse cometary chemistry can be? Or are we staring at a chemistry so odd it hints at processes beyond the natural? And then there are the metals. Spectral lines hint at rare metallic elements, patterns that resemble refined materials rather than raw cosmic dust. Now, I've seen spectroscopy trick even the best of us. Miscalibration, interference, or overlapping lines can mimic the extraordinary. But if these signatures hold up under scrutiny, we may be looking at something forged in environments we don't often see in comets, near dying stars, in regions of crushing pressure, or perhaps in ways we don't yet understand. Imagine holding a meteorite and finding alloys no smelting fire on Earth has ever produced. That's the kind of shiver those reports give me. Some colleagues urge caution. They remind me that extraordinary claims require extraordinary evidence, and they're right. But I also believe that extraordinary evidence often hides in plain sight until we dare to look closer. That's the balance we must strike. Open eyes, steady hands. Now, let's address the rumors, because they have become part of this story. Shortly after discovery, whispers emerged from inside defense networks. A signal, they said. Not a steady broadcast, but a pulse, a mathematical rhythm too structured to be noise. I've lived long enough in this field to know how easily terrestrial interference can masquerade as the exotic. Satellites, ground transmitters, even a faulty cable can play tricks on our instruments. And yet, when multiple observatories were watching the same sky, the timing was enough to make people uneasy. The alleged source seemed to align with 3I divided by Atlas itself. NASA, the Air Force, and Space Force reportedly reallocated resources to monitor the object in those days, though no agency confirmed details. I don't leap to conclusions here. But I can't ignore the fact that such coordination, across institutions that rarely pivot so quickly, suggests something caught their attention. Whether it was merely unusual natural behavior or something more, we may never know. What matters is that the possibility, even the rumor, forces us to refine our methods, to ask sharper questions. And then came the strange behavior of brightness. Comets usually brighten gradually as they approach the sun, their ices vaporizing in predictable patterns. 3. I divided by Atlas has not behaved so politely. Its brightness flickers, dims, and then brightens again, not random, but not easily explained by rotation either. Gemini South, one of Chile's great optical telescopes, even reported light pulses, evenly spaced, almost rhythmic. Were these natural? Possibly. Jets of gas, rotating out of sunlight, could mimic pulses. Plasma interactions with the solar wind could also produce bursts, but evenly spaced pulses? That's rare. Some compared it to a cosmic heartbeat. When I read those reports, I thought of the wow signal of 1977, an unexplained radio burst that still stirs debate. If that signal was a whisper across the dark, then these light pulses, if confirmed, could be a flicker across the void. Avi Loeb, the Harvard astronomer known for pushing the boundaries of our imagination, suggested it might be a deliberate energy modulation, a way of saying, "Notice me." Not proof of anything, but a hypothesis worth testing. And testing is the key. Are these flickers reproducible? Do multiple observatories detect them simultaneously? Are they tied to geometry, or do they persist regardless of angle? These are the questions we must chase down, and fast. Because if the object fades into the distance without resolution, speculation will fill the void. And speculation, untested, is the enemy of truth. NASA knows this. That's why the Mars Reconnaissance Orbiter is being tasked to image 3I divided by Atlas during its pass near Mars. HiRISE, with its ability to resolve objects the size of a kitchen table on the Martian surface, may manage to capture pixels of an interstellar body. It's a long shot, but even blurred dots could reveal shape, rotation, or unexpected features. Combine that with Webb's infrared spectra, ground-based optical photometry, and perhaps Hubble's ultraviolet instruments, and we're building a mosaic of evidence. Every telescope becomes a detective, each adding a clue. Meanwhile, I can't help but think of what SpaceX represents in this story. With rockets that can launch weekly, carrying heavy payloads, the possibility of quickly sending intercept probes to future visitors becomes more real. Not this time, we don't have the time window, but maybe next time. 3I divided by Atlas is teaching us urgency. Interstellar objects don't wait. They appear suddenly, flash across our sky, and vanish forever. If we want answers, we must be ready to act. Still, As I write this, the debate among scientists continues. Some say we're simply seeing a volatile-rich comet, bigger than the ones we've known but still natural. Others argue that its trajectory, its timing, its chemistry, and its flickering light suggest something more. Both sides agree on one thing: we can't look away. Not this time. Not when the universe has placed such a mystery in our path. I'll admit, I lean toward awe. That doesn't mean I believe every rumor or leap at every shadow, but when the data whispers strange things, I want to listen. Because even if the final answer is natural, a comet rich in carbon dioxide, carrying metals forged near a star's violent death, what could be more extraordinary than that? To hold, in our instruments, a fragment of another sun's story? That alone is enough to change how we see ourselves. And yet, there's that other possibility, the one that refuses to die. The thought that maybe, just maybe, this isn't only a piece of rock and ice. Maybe it's a messenger, carrying not just atoms, but intent. If that were true, then every spectrum, every light curve, every flicker becomes part of a conversation across the stars. And the question is not whether they are speaking, but whether we are wise enough to hear. So I ask you, are these signs of nature's wild creativity, or hints of something more? I can't give you the answer yet, none of us can. But I can promise this: we will chase the evidence until the mystery yields what truth it can. And whatever we discover, it will remind us of one simple truth: the universe is always stranger and more wonderful than we expect. When I think about 3I divided by Atlas, I no longer see just a comet. I see a mirror held up to us. Because whether this object turns out to be a natural wanderer or something designed with purpose, the astonishing truth is that it forces us to face the limits of what we believe is possible. That is the climax of this story. Not that the comet has secrets, but that we are finally prepared to ask the right questions. Consider the moment we're living in. Humanity has existed for hundreds of thousands of years, but only in the last blink of cosmic time have we built the tools to notice such visitors. And now, within a single decade, we've seen 3. First, Oumuamua, long and tumbling, hinting at strangeness we couldn't explain. Then, 2I divided by Borisov, a more ordinary comet, yet carrying chemistry that challenged our models. Now 3I divided by Atlas, larger, brighter, stranger, gliding right where our eyes can see it. The astonishment is not just the object itself, it's that the cosmos has sent us 3 messengers in quick succession, as if testing our readiness. So, what have we learned? From the analyses already unfolding, several truths rise to the surface. The carbon dioxide content is off the charts, unlike anything in our catalog of comets. That alone reveals that planetary systems beyond ours forge worlds with wildly different chemistries. The early activity tells us that interstellar objects can wake far sooner than expected, teaching us humility in our assumptions. The reported pulses of light, whether natural or not, remind us how eager we are to search for patterns, for meaning, for a sign that we are not alone. And the whispers of signals, the suspicions around data gaps, the unusual metallic lines they reveal more about us than about the comet itself. They show how quickly our curiosity burns, and how hard it is to balance skepticism with wonder. Here lies the astonishing reveal. The mystery of 3I divided by Atlas is not simply about what island. The true revelation is that we are now capable of investigating with rigor across the globe and beyond it. NASA's Mars Reconnaissance Orbiter will attempt an observation that was unthinkable a generation ago. The James Webb Space Telescope has already probed its chemistry from 1 million miles away at the L2 point. Ground-based observatories in Chile and Hawaii coordinate nightly, their instruments synced by atomic clocks. ESA and JAXA share data streams, pooling insight. And while we argue hypotheses, while some voices say natural and others whisper artificial, the fact remains, we have built a planetary network of eyes and ears, and it is awake. That is the miracle hidden in plain sight. Think about what comes next. If Juno could be retargeted for one last daring mission toward 3I divided by Atlas, we might taste its secrets directly. Maybe it will not happen, maybe logistics and fuel stand in the way. But even the conversation marks a turning point. Because next time, with SpaceX's Starship standing by, or with ESA's planned rapid response interceptors, we may launch a probe within weeks of discovery. We are practicing, rehearsing for a future in which no interstellar visitor will escape unexamined. That is how science grows, by preparing for the question before it's asked. And so, standing here tonight, I feel the weight of a paradox. On the one hand, 3I divided by Atlas may prove to be nothing more than an unusually volatile comet sculpted by physics, chemistry, and chance. On the other hand, it could carry anomalies we cannot yet dismiss, hints of design that demand deeper thought. But both paths lead to wonder. If natural, then this is a fragment of a world born under another sun, carrying in its atoms the story of a place we may never see. If artificial, then it is a messenger across the gulfs of time and space, a whisper that we are not alone. Either way, it expands the horizon of what it means to be human. I can't help but connect this to the future of exploration. Soon, NASA's Artemis program will return humans to the moon, building a base that could one day launch missions outward. SpaceX dreams of Mars colonization, planting the seeds of a multi-planet species. The European Space Agency, JAXA, and others prepare telescopes that will peer deeper into the cosmos than ever before. And here, in the midst of all these human plans, the universe itself has sent us a reminder. We are part of something vast, and visitors will cross our skies whether we are ready or not. So what is the meaning of this moment? For me, it's this. 3I divided by Atlas is not just a comet. It is a question, written across the night, asking us if we are brave enough to see the universe as it is, not just as we expect it to be. It asks whether we can resist the comfort of easy answers and hold space for mystery until the evidence settles. It asks whether we can imagine futures where such visitors are not rare curiosities but part of a dialogue across the stars. And here's where imagination must stretch. Suppose the unusual metals are real. Suppose the flickering light holds a pattern. Suppose, even faintly, that we are looking not only at geology, but at technology. What then? Would we recognize it? Would we respond with wisdom? Or would we dismiss it until history proved us slow to listen? These are not idle questions. They are rehearsals for the day when evidence finally arrives that cannot be ignored. Still, I remind myself, extraordinary claims require extraordinary evidence. Skepticism is not the enemy of wonder. It is its partner. Without discipline, awe turns into fantasy. Without awe, discipline turns into cynicism. But together, they keep us standing at the telescope, night after night, listening for whispers in the data, ready to be surprised. So here I stand, looking at a faint blur of light on the monitor, knowing it is a shard from another star. My pulse quickens, because I feel the presence of something larger than myself. The astonishing truth is not locked inside the object. It is inside us, the recognition that we live in a universe where such things happen, where stars fling pieces of themselves across gulfs of darkness, and sometimes, by chance or design, those pieces pass through our little neighborhood. And so, I leave you with this. 3I divided by Atlas is already slipping away, but its lesson remains. The universe is alive with questions, waiting for us to grow into them. The next time an interstellar traveler comes, will we be ready with ships to meet it? Will we have instruments primed to decode its chemistry, its signals, its secrets? More importantly, will we have the wisdom to greet it with humility, whether it is a silent rock or something more? That is the question I put to you tonight. When you look up at the stars, do you see emptiness or do you see possibility? For me, the answer is clear. The night sky is not a void, it is a conversation. And with 3I divided by Atlas, the conversation has just begun. So here we are, at the end of this journey with 3I divided by Atlas, an interstellar traveler that has forced us to pause, to wonder, and to question what we truly know. We began with the basics, a hyperbolic orbit, impossible speed, and chemistry that refuses to fit into neat categories. We explored the strange whispers of signals, the flickering light that hints at hidden rhythms, and the metallic elements that challenge our understanding of comets. And we admitted what no scientist likes to admit: we don't yet have the full answer. But here's what I carry away. 3I divided by Atlas is not only about the object itself, it's about us. It is a reminder that the cosmos does not bend to our expectations. It throws curveballs, it confounds our definitions, and it dares us to keep our minds open without losing our discipline. For me, that is the true gift of this visitor. When I look at it, I don't just see a comet, I see a reflection of humanity at a crossroads. We are a species capable of detecting a faint dot millions of miles away, of turning orbiters and telescopes toward it, of asking whether we might be witnessing the first whisper of another intelligence. And we are also a species capable of doubt, humility, and patience, waiting for the data to speak. Both qualities, the dreamer's awe and the skeptic's caution, make us who we are. The lesson is simple. In science and in life, the universe asks us to hold tension between wonder and evidence, between hope and proof. If we can do that, we grow not just as observers, but as participants in a much larger story. So, let me leave you with this question. If the cosmos truly is alive with messages, whether written in atoms or in signals, would we recognize them when they arrive? Subscribe so we can continue this journey of discovery together. Because the universe is speaking, and it's far too beautiful to face alone.